Hello students, good evening everyone. I hope you're all good. Good evening everyone.
Good evening,
Good
ma'am.
evening, ma'am.
So I give you another surprise today so that I mean you should be always alert.
Good evening, madam.
Good evening everyone. Nice to see you all because I thought that everyone was asking me that I must conduct your practical practical work also. So I think I have uploaded 3 experiments up till now. The first one was para-nitroacetanolide. The second one was acetyl salicylic acid or aspirin, that is the preparation. And the third one was also, I think, I have a scheme in my hand. I don't remember exactly which was the third one. I just maybe, yes, the shift base. The last one was the shift base, that is benzylidine aniline. 3 experiments I have taught and I have uploaded also on the YouTube, right? So you go through, please them also go through those videos also. That will help you out in getting knowledge about your experimental side, because have you performed any experiment in the lab? I don't think so. You have there was no gas. I think there was some problem, so we have not I think we were not successful in doing the experimentation work there. So now you have to be, even now we are online, so you have to go through everything through these these classes like that. So today I thought the experiment, do you have your schemes with you right now? Please open your schemes if you have. Do you have your schemes with you? Yes, please speak up.
No, ma'am.
So
No.
you are at,
No, ma'am. No, ma'am. वो वहाँ से हैदराबाद है.
you are at home, so why don't you have your schemes with you?
मैम हम दिवाली की छुट्टी पे आए थे, हमारी छुट्टी कर दी बस इन्होंने.
अच्छा, तो आपके पास स्कीम किसी के पास भी नहीं है? You don't have schemes?
No, ma'am.
Ma'am है scheme.
है ना, अच्छे
Yes, ma'am,
बच्चे
scheme
देखें
पढ़ी है.
कुछ. There are some good kids who are saying that they have the schemes. Okay, just tell me, is this group A or group 1?
ये basically
Group A or group B?
Ma'am, दोनों
both are
group.
combined.
Both, okay, both, because Tuba was saying that you people want B group will be taught by their teacher. So I thought that group A will join today and group B will join their teachers from Monday. But if you wish to join my lecture, you are most welcome, because you are familiar with me more as far as I know. आप लोग मुझे ज़्यादा अच्छा जानते हैं. I've been teaching you in the last semester, so I think you are more familiar to my way. So if you wish to join, you are most welcome. Though there are only 42 participants, there are so many. There's a lot more can add up. There's I think 100 of people who can join at one time. So today I thought that I must start with the experiment number 1, that is preparation of phenyl benzoate, and it's a Scotton-Bowman method, right? Scotton-Bowman was a scientist who was successful in performing this experiment, and he tried a number of attempts, and he got to react benzoyl chloride with phenol. And he and what happened then, when he reacted benzoyl chloride with phenol, he got to receive, you got to have an ion in the transition state, that was sodium phenoxide ion, because he used an alkali also. This reaction was proceeded basically in the alkaline medium, right? It was an alkali was added. And what was that alkali? I hope everyone knows the alkalis. Sodium hydroxide was used as an alkali. So he made a solution of sodium hydroxide, that is almost 10% solution, and then he added that solution to that reaction mixture, and he got a product. And he got a transition product, that is sodium phenoxide ion was formed, which was then benzoylated again. This is actually the reaction of benzoylation reaction. You just go through the reaction of how benzoylation reactions takes place. This is basically benzoylation. So that sodium phenoxide ion, it was benzoylated, and then it finally gave us the product, that is phenyl benzoate. Our goal today is to prepare phenyl benzoate, right? From what? From phenol, right? So this is in the presence of an alkali called sodium hydroxide. That is, we will make a solution that is sodium hydroxide. Directly pellets are there. There are different sizes of pellets. Sodium hydroxide pellets are available. I don't know if you have seen, they are white colored pellets. So we use those pellets also, or directly in some experiments, and in some experiments we have to make a solution. So a 10% solution was made. So and that solution was added around almost 8 to 9 mLs of the solution was added to it. So I have this experimental scheme with me right now, and I can read the experiment if you like, but I think that that's not appropriate. I should wait for a second. So can you see this experiment? This screen share, can you see this screen share?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, fine. That's
मैम स्टूडेंट को ऐड करें.
Yeah.
Yes.
I'm sorry. I'm admitting the students. Yes, they are admitted. So this is the experiment, preparation of phenyl benzoate, Scott-Bowman method. Thank God I have prepared these slides. I thought you have your schemes with you, but now it becomes easier. Now here it's simply the preparation first, right? So let's go with the preparation first. So it's simply, you will see that he was the scientist, that is Scott-Bowman was the scientist who is behind this successful experiment, right? So the preparation of this, still people are, joining. I have admitted all. Okay, so the preparation of phenyl benzoate follows basically Scott-Bowman method to achieve benzoylation. As I just mentioned earlier, that this is the process of benzoylation. The reaction progressed by treating phenol with benzoyl chloride, right? By adding an alkali, that is 10% sodium hydroxide. Now, a question arises that how you're going to prepare 10% sodium hydroxide. Maybe some of you know, some of you have forgotten. So I simply wrote down the process of making a 10% sodium hydroxide solution. That is, you simply weigh 10 grams of sodium hydroxide in a very minimum amount of a solvent. You will take a very minimum amount and you will dissolve almost 10 grams. You will weigh on the weighing balance and then you will dissolve it. And you will, in the volumetric flask, we are going to perform this you are going to make up this solution in a volumetric flask. Do you know the volumetric flask? Do you have the idea of volumetric flask? Dekhe aapne?
Yes, ma'am.
Okay, so in the volumetric flask, always we make the percent solutions in the volumetric flask. In the physical chemistry teachers, they are supposed to tell you how to make these percent solutions, but I can also explain you. So you simply measure a 10% sodium hydroxide solution by adding 10 grams of this sodium hydroxide in the very small amount of the solvent. Which solvent we are going to use? We are going to use here distilled water, right? And we will then after adding that, you will shake the flask for a little while, and then you are going to make up the volume up to 100 ml. There are marks there, starting from 1 to 100, and then up to the 100, you are going to fill up with the distilled water, and then you are going to shake that solution very nicely, and this is your 10% sodium hydroxide solution, right? So whenever I'm having a break, there is you always find me that I am admitting people. So that's why I don't know whether you can see that thing happening on your screens. I have to admit again and again many people. So that's why there is a break. So this is how you are going to prepare. I mean, whenever an experiment, organic reaction starts, you have to a lot of reagents. If the reagents are not prepared, then you are supposed to make the you are supposed to prepare the reagents. So what reagent we needed here in this experiment particularly, we needed actually 10% sodium hydroxide. So it is supposed to be freshly prepared. Almost every time whenever you make a percent solution of some alkali, you have to prepare on the spot, that is freshly prepared, right? So this is what is here we have just done. we have prepared this. Now here they said that phenol reacts with sodium hydroxide, forming an ion, right, called sodium phenoxide ion. Now this is the simply as the structure of a sodium phenoxide ion that is formed when phenol reacts with this sodium hydroxide, right, that is this alkali. Because it's a method how you are going to add up. I can explain the experiment if you want. But I have in the next slide. I have drawn the diagrammatic, profile of your experiment so that you can see how the stepwise everything is going on. But here they are saying in a 250 ml flask, you have to dissolve 0.6 gram of phenol in a 9 ml and phenol in 9 ml almost and 10% sodium hydroxide solution, and then add 1 ml of benzoyl chloride. So this is how the experiment goes on. Phenol plus benzoyl chloride in the presence of an alkali, you are going to get this phenyl benzoate. Okay, so let's see the next slide. So this is how the experiment now starts. Here, this is the diagrammatic pathway, which I have, I'm enjoying tea also. Actually, this was the tea time for you people also. I have disturbed you. I'm sorry, but actually I thought that I must go on because from Monday again you have regular classes. So you'll not be having the time in between for these practical sessions. So that's why I planned right now, and I asked to join as much people as can. Okay, we are running out of time. If the class stops, then again rejoin again, because after I think 30 minutes it will, 40 minutes it will again, it will stop. The Zoom cloud, it stops after 40 or 30 minutes. Okay, so come to the point. This is the preparation of phenyl benzoate, and it's a diagrammatic pathway. Now here, these are my horrible drawings, but I hope you are not familiar with my drawings. So this is a 250 ml conical flask, right? Now you are going to you have to put aside a 250 ml flask, clean, dry, and washed, right? And then in the clean, and then rinsed with the, of course, the solvent. You know which solvent, because every time you have to see in the scheme that which solvent they are using. So you have to rinse it finally your glassware with that solvent, particular solvent, right? You have to see the medium of the solvent, which solvent is there. So if the solvent is there and you can see it here, they are using distilled water. They are using the benzoyl chloride is also there, and then for recrystallization they have recommended us ethanol. So you can rinse with ethanol, no problem. So in a 250 ml conical flask, dissolve 0.6 gram phenol in 9 ml. Okay, so they are saying that take a 250 ml flask first, and then in a separate beaker that contains a 10% sodium hydroxide your solution which you just made, you take 9 ml of that and add it into 0.6 gram of phenol, add into this solution of 9 ml solution. In another test tube, you can take another test tube. That was flask number 1. That was 250 ml flask. You have to keep it one side. And this is in a test tube or in a measuring cylinder. You can, add this 0.6 gram of phenol, and you will make a mixture of this. That is 9 ml of this sodium hydroxide solution. You are going to make dropwise, and you are going to shake it when you are adding this phenol to this.
मैम स्टूडेंट्स के पास सेकंड स्क्रीन शेयर नहीं हो रही.
ये वाली नहीं हो रही स्क्रीन शेयर? क्यों नहीं हो रही?
नो मैम, स्क्रीन सेकंड शेयर नहीं हो रही.
अच्छा, अब हो रही है? सॉरी, अच्छा चलें दोबारा से शेयर करते हैं. ओके, आपने पहले बताना था. अब हो रहा है? Can you see?
Yes ma'am.
Okay, sorry. Actually, the first screen was open, so that's why. Okay, so this is, I was just telling them that this is the preparation of phenyl benzoate, and this is the diagrammatic pathway. So here you took the 250 ml flask, and in a separate beaker, you made this solution that is 10% solution of sodium hydroxide. And then you add into that sodium hydroxide solution 9 ml of, you will take the 9 ml of sodium hydroxide, and in a separate in a separate test tube or any glassware, small sized glassware, you are going to add 0.6 gram of pre-weighed phenol, which you have already weighed, you will add that phenol into it, right? Now, again, arrow, you can see the arrow. You will move according to the direction of arrows. And I've given the numbers also so that you can see the steps, what step you are going to adopt after that, right? So you can take the screenshots also of this. I mean, beautiful. I can also take the screenshot, one more screenshot so that you should have a proof. Okay, so after that, you are going to dissolve phenol in sodium hydroxide solvent. Then you are going to add this mixture to the conical flask. This conical flask, again, in the dropwise manner and with with constant stirring or swirling this conical flask. I explained you how to swirl, SWIRL, swirl the flask. I hope somebody still remembers कि कैसे होता है. Okay, so इसको आपने यूं shake करना and then. Okay, now add this to in a 250 ml conical flask. What? You have to add 1 ml of benzoyl chloride. Now, after adding these two things, now you are going to add 1 ml of benzoyl chloride, right? Again, in the drop my minus, in which flask? In number 1 flask that contains your this mixture number 2. In the same, you are going to add 1 ml of benzoyl chloride, right? After that, you are going, this is 4th step, right? Cork the flask. Now, in the glassware, there's a particular glassware that they are using here. This consists of a conical flask, a polymetric flask, beakers, measuring cylinders, and then, of course, cork also. Cork is, do you know what is cork? Cork lagate na upar bottle ke upar, we have to cork the bottle. These are made up of, I mean, brown colored corks, and they are, I don't know if you are, you have seen in the lab or not, but you have to cork it with something, and then you will shake that mixture. Now you have a mixture containing 1 ml of benzoyl chloride plus sodium hydroxide and of course the phenol. So you are going to shake the flask, vigorous shaking. This is called vigorous shaking. That is constant shaking of about, in some experiments they are saying for 15 minutes is enough. In some experiments they are saying, you know, you have to constantly shake for about 15 to 30 minutes, right? So till the solid separates out. Now what will happen, these are all, you know, these are all in they will get dissolved as the sodium hydroxide pellets, they got dissolved when you made the solution. So there is a very little amount of solid was left. So that was all, I mean, in the diluted form, in the solution form. So now after the shaking of this vigorous shaking, you are going to wait till the smell of the benzoyl chloride, it disappears, right? Now, I forgot to tell you that this benzoyl chloride is very, very pungent. It's very toxic, and it's very, I mean, it has the very irritating vapors that can, I mean, goes inside your mouth, even your nose, your eyes will start burning. Even when you'll eat something, you have a bitter taste in your mouth. It is so absorbing, and it goes so instantaneously inside the respiratory system, inside our whole, you know, mouth. So this benzoyl chloride has a particular smell. So they say that the reaction will complete, the reaction will come to the end, and or you can say the reaction period will be over when you will feel that this smell of benzoyl chloride, it is no more, it disappeared, right? So this is the indication that your experimental, I mean, time is over. That is 15 to either 15 minutes, 20 minutes, 25 minutes, it's over, and your product is about to form. So, and this is what they have indicated, till the solid separates out. Here I've written till the solid separates out. Now what is that solid? That is the precipitates of phenyl benzoate, that they will separate out, right? As phenyl benzoate is not water soluble, so it will a little bit be away from the rest of the solvent when you will add cold water on it. Okay. Here I've written till the solid, you have to shake vigorously till solid separates and till smell of benzoyl chloride vanishes, indicating completion of the reaction. Now here also I've written that it will indicate that your reaction is complete when the smell is no more. Okay, fine. So this was step number 6. I don't know where I've gone. Okay, so this is step number 6. Okay, now you are going to add to this mixture, you are going to add 20 ml of cold water, right, into this reaction mixture, and precipitate of benzoyl chloride will form. You will see white precipitates of benzoyl chloride, white powder formed, or white, little particles of phenyl benzoate will be seen. They are very white in color, right? And but this product is crude product. You have prepared successfully, you have prepared your compound, but now it's in the crude form, that is, it's in the raw form. That means it needs to be purified, and for purification, of course, we will adopt the process of recrystallization. And here they have, in your scheme, they have said that the recrystallize the crude product from the spirit, that is, you can use ethanol to easily, recrystallize this compound. Now, how you are going to recrystallize? It's again a very simple process. You will take your product, that is the crude product, you will put it in the inside the filter paper, right? Few 2 to 3 filter papers you are going to keep, and you will press them against those filter papers, and then you will see that yes, there is, the solvent is no more there, and then you are going to you are going to wash the precipitates with the cold water. Then you will wash them with the cold water, right? This is how the process of recrystallization it will goes on. No, you will warm the mixture, and then you will set it aside for some time for cooling down, right? They will cool down at the room temperature, and at the room temperature you are going to, because the whole experiment, it goes on in the room temperature. We do not need any heating source. But because of the smell, the pungent smell, I avoided this experiment to do in the lab. This was one of the reasons. The smell is extremely hazardous. Okay, so you will get. Hello, good evening. Welcome back after the Maghrib prayers. So. Hello and welcome back. So I think we should start now. There are 30 participants, so I think we should start from where we have left. So I was discussing with you about the diagrammatic pathway of preparing phenyl benzoate by reacting phenol with this what you call you will simply react phenol, right? And you will react it with the 10% sodium hydroxide solution, and then you will have added 1 ml of benzoyl chloride, and you cork the flask and shake it vigorously for about 30 minutes. And when white solid separates, you have to wait. And now the completion of reaction, it is when we will simply see, we will feel no smell. Then we will come to know that our reaction period is over, right? So this is what has happened up till now. Are you listening?
Yes, ma'am.
Okay. I can't hear any voice, so that's why I was a bit worried that whether you people have joined or not. Okay, so let me see if it's been recorded or not. Can you see the recording button sign there on the screen?
Yes, ma'am.
Yes, ma'am.
It's been recorded? Okay,
Yes,
fine.
ma'am.
Okay, okay. So this was the diagrammatic pathway in which I've explained you in 4 or 5 steps that in the end we were discussing the end. You have the crude product and then you need to recrystallize that crude product. But where I forgot one step before before filtering it off, you need to wash the precipitates always. So now as we know that benzoyl phenyl benzoate is not water soluble, so you are going to wash it with of course with distilled water. Whenever in the experimental section they are saying that do the washing, so that means they are saying about they are saying about distilled water, nothing else. It's only distilled water. Can you see the screen?
Yes, ma'am.
Okay, okay, fine.
Ma'am.
Okay, so what I was saying that whenever you prepare a product, you have to wash the product with the desired solvent they are suggesting us. So here they have suggested us, I think distilled water they have done. They have again suggested, yes, add 20 ml of cold water to the flask, filter the crude phenyl benzoate section, wash with cold water, drain well, and dry by pressing between filter paper layers. This is what I was just telling you, that you have to press it between the folds of the filter paper. 2 to 3 filter papers you are going to put one on top of the other, and you are going to press it, and then you will see that it's almost dry. And then you can, if preferable or if recommended, then you can put it inside the oven for some time. If your oven is working nicely, then put it there for some time. But you know, the melting point of this product is not very high. It's 69, almost at around 69 degrees centigrade it's going to melt. So you have to keep the temperature of the oven a bit lower, so that your compound should only dry, only the solvent should be evaporated or dried off from that, right? So even at the room temperature, it will it's recommended that you at the room temperature you should dry your compound. Just put it at one side of on the table and leave it there for about 10 to 5 minutes, and it will be dried. You do not need any oven drying in this experiment, because this experiment it never needed, it never needed the heating source. It went on the at the room temperature. So this was one of the points you need to remember. So this was the diagrammatic pathway I just shared, right? So in the end, now after washing, you are going to, of course, you have to filter it off, and then you are going to wash the precipitates with cold water. You are going to, of course, you will be having white colored precipitates, which I just mentioned it to you, that you will get the white precipitates, which are going to fold again in the folds of the filter paper, and you will dry them and you will keep them at one side, right? And this is the precipitates in the end, in the red. I've made a red drawing so that you can have full focus on the red color of the precipitate, though they are not red in color, they are white in color. Okay, keep that thing in your mind. It's just for gaining your attention. I chose the red color. Okay, so let me close this slide. Okay, no, this is not the slide. Okay, this is the slide now. Can you see? Preparation of phenyl benzoate diagrammatic pathway.
Yes, ma'am.
And
Yes, ma'am.
the ending slide of diagrammatic pathway. Now it is a little bit, maybe difficult for you people, because you don't have your schemes with you. If some of you have schemes with you, you can compare your scheme with your diagrammatic pathway, and you will see that yes, it is just the same thing, but I am explaining you through diagrams and through a number of different steps how you are going to, which glassware you are going to use, and how you are going to measure, and how you are going to make a solution, how you are going to mix it up, and how you are going to warm. There are a number of steps, and you see here it's the 14th step. You are going to get your final product in the end. It's the 14th step. So now after that step, when you got the precipitates, in that slide, in the previous slide, you were left with this red colored precipitates. I mean, the precipitates are white, but my handwriting in red color. And then you are going to use hot ethanol, right? You will add hot ethanol because now you have the crude product, you have the raw product. Crude product, you also can call it, and you can also call it raw product, right? So you have that. Now you need to recrystallize it. So they have recommended us ethyl alcohol, because ethyl alcohol is always the best solvent to recrystallize or get back the precipitates, right? Whenever whatever precipitation is you want to need, I mean, the nature of this solvent is so friendly that it gets your precipitates back, right? It has the friendly nature. Even when I used to prepare my polymers for my or resins in my PhD project and in my MPhil project, in my MPhil and PhD's coursework and in my research journey, I had to, I mean, use ethyl alcohol most of the time, and this was such a friendly though my polymers were not at all dissolving in ethanol, we used to dissolve in DMF, that is dimethyl formamide and dimethyl sulfoxide. These are the toughest solvents in which everything, almost everything, it dissolves. So because this question is not that in recrystallization that you only need to dissolve. No, you have to get back or recover back the precipitate. This is the success of your recrystallization, that you get back your precipitates once they are dissolved in the solvent, whatever XYZ recommended solvent is there. Okay, you dissolved it, right? And sometimes they are not getting dissolved in the room temperature, so you need to warm them on the, I mean, on some heat source, and then you have to wait it at the room temperature, then leave it for the room temperature. If you see the crop of crystals are getting back, and then you will see, oh yes, they are getting back, fine. Then you do not need anything. You have to keep it there for at least 2 to 3 hours. Leave it there, and you after some time, after 2 to 3 hours, you will come, or on the next day, you will see that your crop of crystals are there, right? You will simply filter them off, and you have your product there. Simple. But if you do not get it in this way, then you are going to, I mean, give it a boil. You will dissolve it, and you will filter it off on the spot, and then you are going to, I mean, you have to wait for filtrate, that what is left at the bottom, right? That is the filtrate you are going to keep, and you are going to reduce the volume. You have to keep it for a while to see whether, you have to check it, that whether your precipitates are there or not. If they are not forming, and 5 to 10 minutes you have waited, and if they are not forming, then you will see, yes, maybe the question arises, the solvent level is a little bit higher, so you are now going to reduce the solvent, okay, on the flame. In the class demonstrations also, in the lab demonstrations also, I have I've told this thing again and again, that you have to reduce the volume of the solvent when you do not get the precipitates in the synthesis even, and even in the recrystallization also, both the things. So in this way, they said that just add in our experiment. Now we talk about our experiment. I was talking in general. Now in this particular experiment, they are saying that take a hot ethanol. That means you have to warm the ethyl alcohol in some container, and then warm it or boil it, give it a boil, okay, and put your compound precipitates inside it. Mix them thoroughly, keep with a glass rod, keep stirring till your whole compound is dissolved in it, right? Then warm it for a while, see if something happens, fine. Nothing happens, just keep it at one side and let it cool for some time. Here I've also, on step number 12, we have seen that cool. Okay, after some time, you will see that you are having the dry crystals. That is the pure form, the purest form you got after the process of recrystallization, right? Then after recrystallization, you will see that your compound, keep it aside. In this case, I'm talking about keep it aside, because we have not used the oven. We do not need oven drying in this experiment, because it's going at low temperature. We are getting the product at the low temperature. So we do not need oven. Oven is not recommended in this particular experiment. Somebody can ask you why oven is not needed in that experiment. So you should come up with these answers, that its melting point was already very low. So we do not need to, I mean, we tried to put it at the room temperature first, so that we can see if we are getting the product. So fine, we don't need the oven. So it's just because that the melting point of this compound, phenyl benzoate, is 69 degrees Celsius, right? So its melting point is low. Okay, after you, I mean, got the product, after you have this pure form of crystals, I mean, you are now happy that at this stage you feel a bit happy, a bit successful that yes, you have your product now, it's recrystallized also. Now you are going to record the melting point. Though the rule is that, the principle is that you must, whenever you are going through the process of any organic synthesis, you must record the temperature before recrystallization, and you must record the temperature after the recrystallization, and you must monitor the difference in the temperatures. That before recrystallization, what was the temperature, you have recorded with a date, and after recrystallization, what happened. After recrystallization, your compound gets more purer, right? So is there any effect of recrystallization on your compound? It gets purer, so does your melting point gets higher, remain the same, or gets lower? So that also depends on sometimes. So these are all the very important things which you are, not going to, find in the books easily. This all I got from the lot of experiments I have done in my life. I have prepared a lot of compounds in my life. So this is the experience I got from the experimental work I did, and I have a lot of experimental experience during my MPhil and PhD. So that's why I am telling you all these things, because you gain this knowledge with a number of years you have spent or you have invested in your in your research work, or in your masters, or in your MPhils, or in your PhD levels, right? So these things will all help you out someday. These things will come to your mind that yes, our teacher, she told us these things, and now at the master's level, we are getting benefit from it at the MPhil level, at the PhD level. Maybe these things will help you out when you will go through the process of recrystallization, when you will synthesize your compounds on your own. Synthesis is not easy. Organic synthesis is one of the toughest things to do, because you have to deal with a lot of carcinogenic compounds, right? And I don't know how many of these reagents are carcinogenic. I've not read them, but I think so that they are so pungent, especially this benzoyl chloride. I'm so afraid of this compound. It just simply gives you such a bad bad, your condition becomes so worst after doing this experiment. You cannot eat anything after 4 or 5 hours. You are unable to eat anything. It becomes, your mouth becomes so bitter, just like aapne koi kadwa badam kha liya. It will keeps on like that now when you are dealing with benzoyl chloride. And your eyes, you will constantly, you will have tears. Aapko aankhon mein se aansu aate rahenge. You will keeps on dripping, and the tears will keeps on falling. Everyone will ask, why are you crying? But you can't tell them you are dealing with this benzoyl chloride. So that's why I avoided this experiment when we didn't have the heating source available in the last months. Otherwise, I could have group B people. They tried to do it, but they couldn't accomplish the yield. So I never tried. That's why, because it's a tough experiment. It's a torture for the students. It's for us, because we don't have the fume hood there. This experiment is recommended in fume hood. Keep this thing in mind. What is fume hood? Can somebody tell me what is fume hood? Yes. Can anyone tell me what is fume hood? F-U-M-E, fume, H-O-O-D. Have you ever seen a fume hood?
No, ma'am.
You have never seen a fume hood. I can't believe it. In part 3 lab, you have seen at the right side, there is a wooden, compartment that is always, at the upper level, and we have to push it down. That is a fume hood
Ma'am,
for the exhaust in it.
ventilation device होती है.
No, it's not a ventilation. It's for fume hood is something where you are going to, you're going to avoid the fumes, right? And there is a exhaust fan inside the fume hood, and hood means एक दरवाजा सा उस पे लगा हुआ है, and it will close down, and you will open the this button of that exhaust fan, and it will suck out all the air, the toxic vapors, whatever you're doing, and your hands are on the inside that fume hood. That's it. You are away on, and that shutter is down, or the glass door is down, and your hands are only inside it, and you are performing the experiment. This is called a fume hood. So this experiment is recommended for only being done in the fume hood, right? बाहर के पढ़े लिखे लोग हैं ना, उनको आप बताएंगे ना, वो हंसेंगे कि without fume hood आप कैसे, how can you do it? And so that's why I avoided this experiment, because it has so many hazardous things. And our teachers, they never told us, and we went through all these stages, and we are now having so many diseases. But now I have to tell you that this is something very dangerous, and one should not play with anyone's life, right? So this is this experiment is supposed to be done in the fume hood. Even you can say that all the experiments are supposed to be that are relevant to your organic synthesis. They are supposed to be done whenever you are mixing the reagents, you are mixing with the, you are dealing with the organic solvents, you need a fume hood there, right? It is supposed to be there, and the exhaust fan, it should sucks out everything, and only your hands are inside it, and hands are also with the gloves, right? You're not without gloves, you have a mask, you have gloves, so now your hands are inside, and you are not inhaling them, right? Because the inhalation, it kills, simply kills. So now back to our experiment. So on this slide, after you got the crystals, you record the melting point. Now here in our labs, we have, the classical method of recording the melting point, but there is a Gallenkamp apparatus of melting point device that has got, 3 slots in them, and you can easily, and there are, the fine tubes that are used to record the melting point. You will fill your compound in that capillary tubes, and then you will put them inside, and there's a digital, a monitor over there, and you can see at what temperature your compound melts. So there is a digital balance. Digital balances are there, and people do not use the classical method, what we are doing by using that, the paraffin oil and what else. But when we have nothing, we say, oh, thank you, Allah Pak, we do it with this method. We can, we will not stop our work, and we will, use this method. The classical method is always there. The paraffin oil is always there. The melting point, you always record through these, methods. These are always available. But in the advanced stages, when you are doing your MPhils, when you are doing your PhDs, you do need a proper melting point apparatus, right? In which that is digitally monitored, okay? So, so the recorded temperature of your phenyl benzoate is around 69 degrees centigrade. Here, you can see here, okay? So, this is how you prepare your, your phenyl benzoate, okay, by reacting with phenol, okay, and adding a 10% sodium hydroxide solution, and you got an ion that is called a phenoxide ion, which was then benzoylated, and you got the product, right, that is called phenyl benzoate. This is a reaction of benzoylation. So just go through what is benzoylation. Okay, so this is how you get. Now, you are going to, in the slide, can you see the new slide, preparation of phenyl benzoate, to calculate the percentage yield of phenyl benzoate? Can you see the slide? New slide?
Yes.
Okay.
Yes, ma'am.
Okay, I have explained a full video I've uploaded on how to calculate the percentage yield, how to calculate the theoretical yield, how to calculate, how you come to know the practical yield. What is practical yield? Please tell me. I would be happy to know if you will answer me. What is practical yield? Anyone can reply, please, anyone. You're most welcome to reply.
Experimental yield जो होती है वो होती है practical.
वो क्या होती है what बेटा? What is experimental yield?
जो experiment के through हम calculate करते हैं.
अच्छा. Anyone else?
Ma'am, actually practical yield is actual, or we can say that.
Yes. Actual what? Actual what, beta? Yes, anyone else? What is practical yield? आप लोग books में से ढूंढ रहे हैं? Are you finding from the books? You will not get them from the books. इतनी जल्दी तो नहीं ढूंढ लेंगे भाई. Okay, I tell you, you have prepared the compound, you have been given the object, prepare phenyl benzoate, fine. So now when you were preparing phenyl benzoate, right, you got the product in the end, which you recrystallized it, and then you weighed it, right? This is called your practical yield, okay? This is your practical yield. whoever girl was replying, she was correct, but she was not telling me in the correct way that, madam, what we have synthesized in the lab is our actual practical yield. Okay? Ab samajh mein aaya sabko? Everyone got it? What is practical yield?
Yes, ma'am.
Okay. So now boldly explain, answer this question to everybody, that what is practical yield. Of course, the compound you have prepared in your lab, which the assignment which have been provided to you to do it, and the product you got in the end, and you weighed it, you recrystallized it, and then you weighed it. This is called the practical yield. So now in this slide, particularly, you have phenol and benzoyl chloride. The equation is there. Then you reacted with sodium hydroxide, that is 10%, and you got your product, that is phenyl benzoate. Now there is a starting product and the ending product, right? Starting product has got the molecular weight. So the molecular weight of phenol is 94.11 something grams per moles inverse something, right? And if you see the molecular weight of your ending product, that is your product phenyl benzoate, it's 198.22 grams, right? So there is a lot of difference between the two molecular weights. Okay, the starting material has a lesser weight and the ending product has a higher weight, a molecular weight. Definitely, but groups are attached to it after the, I mean, it's the product, so it will gain more weight. So now, when you are going asked to calculate the practical yield, you need to know, number one, the theoretical yield. Number two, the practical yield. Practical yield, if for example here, just to assume, I wrote 0.4 grams. You can see here, here, this is practical yield, and I wrote 0.4 grams here. Okay, now you need to calculate the theoretical yield. What is theoretical yield? Because you do need to have these two values for putting them inside another formula when to calculate the percentage yield of your compound, which is over here, which is percentage yield equals to practical yield over theoretical yield into 100. So for solving this formula, you need to calculate the theoretical yield. So you have here 94.11 grams of phenol right here. You can see the molecular weight. So you will write it like that. That 94.11 gram of phenol gives how much amount of phenyl benzoate? 198.22 gram of phenyl benzoate. So 0.6 grams. Now from where 0.6 grams came? From your scheme. Here in the scheme, you took how much amount, the starting material. This is called the starting material, 0.6 gram here. It's written 0.6 grams. So the starting material, you're going to you have to put it there, and you have to divide 198.22 upon this this one, that is the starting material, that is 94.11. that is, these are the two values, that is the molecular weight of your product and the molecular weight of your starting material into your starting material, which you got in the end, right? That is which you took initially. You took 0.6 grams, right? So in this way, when you divide this and you multiply with 0.6, you are going to get an amount which is around 1.26 grams. So this is your theoretical yield. Now you have both the values, your practical yield, your theoretical yield, and you are going to put it over there. You're going to put, if just for assuming you weighed your practical yield, it is about 0.4 grams. We will put 0.4 grams up. You will divide it with the theoretical yield, that is 1.26, and you will multiply with 100, because percent means 100. Keep this thing in your mind. Whenever somebody says percent means you have to multiply or do something with percent, with 100. So this is 100, and you got the percentage of your compound, that is 31.74% of phenyl benzoate was prepared when you react phenol with sodium hydroxide and benzoyl chloride, and you got phenyl benzoate in the end. And a byproduct was also formed, that is sodium chloride. It was also, I have shown here. So in this way, your problem is solved, your object is achieved, that you first of all, you synthesized your phenyl benzoate, right? You went through the whole process of synthesis, you wrote the equation, right? The equation is there, and then you did the mechanism. It's a simple mechanism of benzylation. Just go through it. It's very easy. And then you went through the process of the full experimental diagrammatic way. That is how it was done. There were 14 steps in this experiment which you accomplished, and then after that you did the calculation, and calculation is always done at the left page of your journal. आपने left side है जो journal की, उसके ऊपर, if this is your journal, for example, if this is your journal, तो उसकी जो left side है, here you are going to do the calculations, and here you are going to write down your experiment. That is experiment number 3, object, glassware, and everything, the way I told you in the lab, in the demonstrations. So you have to do it, follow that, the same pattern in the journal. So please write down now experiment number 1, that is para-nitroacetanilide. The same way you will adopt for preparation of aspirin, that is acetyl salicylic acid. And then the third one, today's one, that is preparation of phenyl benzoate. And iske beech mein bhi something about that. Yes, the preparation of benzylidine aniline. This is the 4th experiment. So I am going to conduct your exam from all these experiments, and I'm uploading them on YouTube also. Inshallah, today I will upload this lecture also. So you will easily see how it went through. There are only 4 slides, no more. Only 4 slides I have prepared. And just go through these slides, open your scheme, read the experiment, write it down in your journal, do the calculation, and you will get your answer. And for the practical yield, as because you are not performing in the lab, so you can assume it 0.4 grams. I assumed it, and I wrote it over here that आपका जो product बना वो क्या था, 0.4 grams था. हम assume करके लिखेंगे, we will write it down, and then you will simply do the calculation. And this way, you would one experiment. This experiment will be complete. Yes. Now, if you have anything in your mind, you can ask me. I'm here.
मैम एक क्वेश्चन ये था, यहाँ पे तो आपने प्रैक्टिकल यील्ड जो है वो अज्यूम की है कि 0.4 है, लेकिन अगर हम कंपेयर करें, अगर हमने फॉर एग्जांपल वेट किया हो तो हमारे पास फिर भी डिफरेंस आता है प्रैक्टिकल और थ्योरेटिकल यील्ड में, तो उसके क्या रीजंस हो सकते हैं कि हमारे पास जो है वो डिफरेंस आ रहा हो?
बेटा डिफरेंस तो यहाँ पर भी आ रहा है ना, आप यहाँ देखें डिफरेंस तो आ रहा है ना, यहाँ पर भी थ्योरेटिकल यील्ड इज डिफरेंट, इट इज कैलकुलेटेड.
मेरा क्वेश्चन यही है कि उसका रीजन क्या है, मतलब
उसका रीजन ये, because practical yield you are going to get when you will prepare your compound. It will go through a number of series of steps, right? First you had the crude product, आपने एक box में से निकाली, and then you applied a lot of chemicals, you reacted it with so many reagents were reacting together, and then you got a crude product, and then that crude product was recrystallized, and then you got the melting point, right? और आपने अब उसको फिर then you dried that compound, and now it is solvent free. The weight of the solvent is not there. That means now, I mean, it's the weight you are going to get after weighing it in the on the weighing balance will only be of your compound. You will minus, I mean, you will null that weight of the paper, and you will get the your weight of your original compound. Whereas the theoretical yield is always calculated through your molecular weights of the compound. That is your starting material and the ending product you got in the end. You're going to divide these two values, and you are going to multiply it with the starting material you took. That is how much amount you took in the beginning of the reagent, of the main reagent, right? So that was 0.6 grams in this case. So in that way, they will never be the same. It's just, you can say, it would be a miracle that both the values are same. How could be both values be same? I don't think so. There is difference always, because both are found through different patterns. One you got through a number of series of steps, and you got a product in the end, right? And you weighed that product. That is the weight of your compound. The practical yield is the weight of your product, whereas the theoretical yield is only calculated through the molecular weights. Okay, I hope you are not, I hope you आपको समझ थोड़ा सा आया होगा.
Yes मैम, आ गया समझ में पूरा.
Very good. चलो फिर थोड़ा सा अच्छी बात है. This is very good. Yes, anyone else? Today we have time. देखें आप आराम से हम बात भी कर सकते हैं, and I can ask you, I can answer you easily. So now please do these 4 experiments in your journals, right? Put them with the dates. I hope you will follow and if you can't, I know I have seen that you people are not following me on the YouTube. So please LMS को खोलें, LMS के ऊपर भी हैं, they are all on LMS and on the YouTube, because we cannot upload everything directly on the LMS. Their space is very short there. So we have to first upload on the YouTube, and then we have to put the link on LMS. So when you click the link on LMS, you will be able to see the theoretical side and the experimental side there. So go through them.
मैम एक सवाल है.
जी बेटा. आसान पूछिएगा.
नमक है?
Yes.
नमक है?
Yes, beta. Please. I'm sorry, I can't hear you. Hello.
हेलो मैम.
जी जी. Yes, please बताएं. Yes.
मैम आपके टूथपेस्ट में नमक है? नमक.
टूथपेस्ट में होता है, बिल्कुल, ऑफ कोर्स होता है.
मैम आपके टूथपेस्ट में है?
क्यों? ये कौन सा सवाल है बेटा? It seems funny to you, but मुझे इतना मजा नहीं आ रहा सुन के. नहीं होगा मेरे टूथपेस्ट में. और कुछ?
मैम ये आउटसाइडर है, हमारे क्लास का नहीं है.
कोई बात नहीं बेटा, इट्स ओके. आप मेरे बच्चे हैं, यू आर ऑल माय किड्स. यू कैन आस्क एनीथिंग. आप यू कैन मेक, आई मीन, थिंग्स lighter. We are in the lighter mood, no problem. But I think it's good if we should not hit personally. Personal hits नहीं देनी चाहिए ना. It's not good. Everyone has flaws. Everyone has negative and positive things both. So I'm a person who points out at the bad things. No, the negative things. No, it's not bad. It's not bad, but it's negative. It's not a good comment or a good question. Anyway, so I hope you like my lecture today. Pasand aaya aap log ko? Did you like? Did you understood?
Yes, ma'am.
I'm happy.
Yes, ma'am.
If my kids, if my students are happy with me, I'm happy that I achieved a goal. Just look at the time and look at the, I mean, I have so many other things on my mind, but I am, and you are also there. So I am appreciating that you took out this time and you are attending my lecture at this time, because I have not been provided the timetable for practical work up till now. So from Monday again, you will have the series of classes. You will get tired. So I thought that I must conduct it on this day. So thank you very much. I think we should end the meeting now. Okay, so see you inshallah next time with something new, something more surprising, something more interesting, which will gain your all attention, and which will force you to attend my lecture. Okay, goodbye.
Goodbye.
See you.